Okay, so today we're going to talk about the multiplication and addition rule. For purposes of what we're going to work with, we can think of multiplication as the word and we can think of addition as the word or. Okay, that's going to come into play as we continue through today's lesson, but those are kind of the key words that we will look out for to let us know, hey, are we going to multiply our probabilities together, or are we going to add our probabilities together? So starting off with new vocabulary, a compound event consists of two or more simple events. Compound events can be either independent or dependent of one another. Okay? So the key to a compound event is, again, that it is two or more simple events, two or more events occurring. Okay, an independent event is two events are independent if the occurrence of one has no effect on the occurrence of the other. They are independent of each other. They do not impact one another. Okay, the probability of two independent events both occur is the product of the probabilities of each independent event. Okay, they can also model it using this right here, this formula. Okay, then a dependent event. It is when two events are dependent if the occurrence of one changes the occurrence of the other. So one impacts the other. So I really just think of like science class where you talk about independent and dependent events and variables quite often. So dependent, they depend on each other. Independent, they do not need each other. Okay, so jumping right in, example 1 says determine whether the following events are independent or dependent. Okay, so the first one, a coin lands heads up and then a second coin lands tails up. Okay, does one event cause the second event to occur? Okay, no, it does not. So I would say that these events are independent of one another. Okay, B. Two cards are picked from a standard deck of cards. The first card is drawn. Without replacing the card, a second card is drawn. Okay, so we're talking about the same set of cards, same deck of cards. Okay, and as soon as I draw that first card, I'm not going to put it back in the stack. Okay, so now my odds of drawing that second card are decreased by 1 because I didn't put that one back. So I would definitely say that these events are dependent of each other. Whatever card I draw first is definitely going to impact whatever card I draw second, especially since I'm not putting that first card back in the deck. C, a 6-sided die is rolled twice. The first roll is a 2, and the second roll is a 3. Okay, so yes, I am rolling the same die both times, but I'm not like taking off a side of the dice like I did with the cards up above where I didn't put the card back in the deck. I can't like eliminate a side of the die. Okay, so these events have nothing to do with one another. I'm rolling just a standard die twice. So I would say these are independent. Okay, last one, there is a raffle to see who gets to shoot for prizes at halftime. 3 people will have the opportunity to shoot. Each time a ticket is drawn, it is set aside because a person can't shoot more than once. Okay, so D is really similar to B where they gave us that key of like without replacing. Same thing here. As soon as a ticket is drawn, it can't be drawn for a second time. So these events are definitely dependent. Okay, moving right along, let's jump straight into some examples here. Okay, example 2 says that Toodles has a bag of 12 marbles in it. There are 4 blue marbles, 5 orange marbles, 1 purple marble, and 2 red marbles. Find the probability of Toodles reaching in the bag and selecting a red marble, then a purple marble without replacement. Okay, so let's take this piece by piece. First of all, they're asking for probability. And last week when we learned about probability, we thought of it as a fraction. Okay, and we thought of it as chance over our total. Okay, So that means that they want me to set up some fractions here that represent the marbles that are being selected. Okay, so the first marble that they're selecting is red, and then the second marble that they're selecting is purple. Okay, so now I need to find my fractions that represent each of these marbles. Okay, so the chance of me drawing a red marble is 2, because there's only 2 red marbles in the bag. Okay, and my total number of marbles in the bag is 12, so there's my probability for red. Okay, then purple. My chance of drawing a purple is 1, because there's only 1 purple marble in the bag. But we need to go back to these 2 words that I highlighted in yellow, without replacement. So that means as soon as I drew a red marble, I now had how many left in the bag? 11. Okay, and I didn't replace it, meaning I didn't put that 1 red marble that I drew back in the bag. I left it aside, I set it aside. So that means my total that I can now pick from to pick a purple marble is now 11. Okay, and here I'm going to multiply my events together, okay, to give me 2 over 132. Or if I reduce it all the way down, 1 over 66. Okay, so that's my probability of drawing those 2 options of marbles. Now, the reason I multiplied them together is because it's a compound event. More than one event is occurring. Okay, so we said that those events could be independent or dependent, but they are represented typically by the product, the multiplication of those 2 events. Okay, so looking at B, they want us to now find the probability of reaching into the bag and pulling out a blue marble, tossing it back in. Ooh, that's key, so I'm going to highlight that. And then selecting an orange marble. Okay, so I'm going to set it up the same way I did on the last one. So the 2 colors that I'm pulling are blue and orange. And again, if they're asking me to find probability, they want me to set up fractions where it's chance over total. Okay, so blue marble was pulled first, so the chance of getting a blue marble is 4 out of my total of 12. Okay, then my chance of selecting an orange marble is 5. Okay, then we need to go to that highlighted word to figure out what kind of total we have. I tossed that blue marble back in. So I did not change my total amount at all. I still will have 12 total marbles to choose from. Okay, now again, this is a compound event. More than one event is occurring. So I'm going to multiply them together. And when I do that, I should be getting 5 over 36 as my probability. Okay, C, find the probability of reaching in the bag and selecting a red marble, then a blue marble, then another blue marble without replacement. Okay, so again, I'm going to go through the same exact setup. First marble I draw is red. Second marble I draw is blue. Okay, then the third marble that I draw is also a blue. So there's my setup here, and I already know that since this is 2 or more events that are compound, they're all going to be multiplied together. Okay, so the chance of getting a red is, let's see, 2 out of a total of 12 marbles. Okay, then the chance of getting a blue is 4. Okay, but I'm not replacing the marbles back in because it says without replacement. We highlighted that in yellow there. Okay, so if I already drew out 1 marble, my total now is only 11. Okay, now, this is where you have to be careful drawing this last marble. We're drawing another blue marble, and it's without replacement. So if I started in the bag with 4 blue marbles, but I didn't put it back in, I now only have a chance of getting 3 blue marbles. And again, my total is decreased by 1, so 10. Okay, so when we multiply all of those together, reduce our fraction, we should be getting 1 over 55 as our probability. Okay, moving right along to example 3. We're going to use this spinner off to the side, and you will notice on yours, obviously it just copied in like a grayscale. So you may want to jot down that like these 2 are purple. This one right here is red. And obviously you can see my colors on my page, but I'm writing for you what you should probably write on your page. So these are blue. and then these two right here are yellow. The color of the number of spaces is going to be important on this problem as well. Okay, so part A says, what is the probability of the spinner landing on 6, then landing on yellow? So we're going to do the same exact setup that we did on this last problem. I have 6 as an option and then yellow as an option. Again, if they want probability, they want a fraction, that is chance over total. Okay, so first of all, the 6, that was spun first. Okay, what's the chance of getting a 6? Well, I only have 1 6 on my spinner, so my chance is 1. How many total spots do I have on my spinner? 8. Okay, these are compound events, so they're going to get multiplied together. Okay, then the chance of spinning and it landing on a yellow. Okay, well, I have 2 spaces here that are yellow, so my chance is 2. Okay, again, out of the total is 8. Now, the reason I'm not decreasing the total is because I'm not taking, like, a piece of the spinner away. Okay, like, we landed on the 6 the first time. I didn't, like, remove that part of the spinner. Okay, so they still have a chance of 8 total spaces to land. So when I multiply these together, I get 2 over 64, reduce my fraction down, and I get 1 over 32 as my probability. Okay, part B. What is the probability of the spinner landing on red, then landing on an even number? So red and even. Those are my 2 events being multiplied together. Okay, probability of getting a red, my chance is 1 out of total, which is 8. Okay, then getting an even, my chance of getting an even would be 1, 2, 3, 4. And again, as soon as I spun and landed on the red, I didn't remove it from the spinner, so I still have a total of 8. Okay, so when I multiply across, I am getting 4 over 64. Reduce that down to 1 over 16. Okay, C. What is the probability that 2 consecutive spins result in prime numbers? Okay, the word consecutive, that just means back to back. I spun once, then I spun again right behind it. So these 2 spins are resulting in prime numbers. So spin 1, prime, spin 2, prime. Again, these are compound events, so they're getting multiplied together. Okay, now our primes, these are numbers, and we still kind of struggle with these. These are numbers that only 1 in itself can create. Okay, so like if I multiply 1 and this value together, I only get this value. That's the only combination that will work. So like the number 2. The only way I can make 2 is 1 times 2. So that would be prime. Okay, 3. The only time I can make 3 would be 1 times 3. Okay, 4 won't work because I have 2 different ways to make 4. I could do 1 times 4 or 2 times 2. So 4 is not a prime. 5. Okay, that's another prime. 6 won't work. 7 is a prime. Okay, that's all my primes right here. Okay, so for my first spin, the chance of me getting a prime is 4 because I have 4 prime numbers out of a total of 8. Okay, then I spun back to back, and again, I didn't like remove a piece of the spinner, so my total is still going to be 8, and my chance of getting another prime value is 4. So 16 over 64, that reduces down to 1/4. Okay, example number 4. You have an equally likely chance of choosing an integer from 1 through 25. What is the probability of an odd number is chosen given that it is greater than 15? Okay, so I'm going to recommend that you take a second and maybe list out your values if you're really struggling with a problem like this, because we should not be guessing on our values at all. Okay, because it is easy enough for you to write out the numbers 1 through 25 to be able to visualize it. Okay, so this one has multiple things occurring at once. So not only are we selecting an odd number, but that odd number that we're selecting has to be greater than 15. Okay, so if we're thinking about our values 1 through 25 that are odd and greater than 15. Okay, so if we start at 15, but we can't include it because it doesn't say greater than or equal to, the next odd number would be 17, 19, 21, 23, and 25. Okay, so there's all of my odds right there. So if I'm setting up probability of this event occurring, then my chance of landing on not only an odd number, but an odd number greater than 15 is only going to be 5, because that's how many total odd values are greater than 15. Okay, but then we need to figure out what is our total. How many total values are greater than 15? So again, we could list them out for ourselves. I already took care of that odd piece. Now I'm just trying to figure out how many total numbers are greater than 15. So not including 15, we have 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25. So I'm getting a total of 10 values that are greater than 15. Okay, again, so I treated each of these as its own separate event. So odd was first, listed here, so all the odd numbers that were greater than 15. Okay, but then I needed to know just how many total values are greater than 15. Set it up as a probability, chance of odd out of total. Now I'm going to reduce this fraction down to 1/2. That's my probability. Okay, continuing on, we're just going to do a few more here. So let's look at example 5 here. It says that a spinner is divided into 10 equal sections that are numbered 1 through 10. Let A be the event that the spinner lands on an odd number, and let B represent the event that the spinner lands on a number less than 5. Find the probability of A and B both occurring together. Okay, so they're wanting us to find the probability of event A, which we said was landing on an odd number. And this symbol right here means and. Okay, so then event B is that the spinner lands on a number less than 5. Okay, so that's what they want us to find right there. The probability that the value we land on this spinner is odd and less than 5. Okay, well, if you don't, again, know how to start, we could always just start by drawing ourselves a spinner. There's nothing wrong with that. It needs to have 10 sections. Okay, so there's my spinner, and I'm going to label it 1 through 10. Okay, now I'm going to go back and I'm going to highlight numbers that meet the criteria for the first one, odd. That's my first event. So all my odd values I'm going to highlight in yellow. So odd, 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 and odd. Okay, but I'm also asking that my spinner lands on a value that is less than 5. So out of these odds, I'm going to go back and only circle the values that are less than 5. So 1 and 2. Okay, so now I'm going to use these values to set up my proportion. So the chance of landing on a number that is not only odd but also less than 5 are only the two that I circled in green. Okay, now my total though, my total is the number of spaces that are on my spinner, so 10. Okay, now if I reduce this proportion down, I get 1/5. Okay, number 6. You roll a die 2 times. What is the probability that you roll an odd number and then roll a 3? Okay, so I have 2 events occurring. I have odd and 3. Okay, so they're compound events being multiplied together. And our total for the first one, if I'm rolling a die, is 6. And they want to know odd. Well, what are all my odd values on a die? I have 1, 3, and 5. So I have 3 chances out of a total of 6. Okay, then what is the chance of rolling a 3? Well, there's only 1 3 on the dice. Okay, and again, I'm not like removing a side of the dice, so I still have a total of 6 sides. So if I multiply, I have 3 over 36. Reduce that down to 1/12. Okay, last example we're going to do is example 7. And it says you roll a 6-sided number cube, so a dice, and they want to know what is the probability of rolling a 2 or a 5. Okay, so I highlighted that key word there. All the other ones that we've been talking about have either had the word and given to us as a keyword, or it's been like an assumed and, like the events were being combined. This one is saying that I want either or of the events to occur, not both together. Okay, so if I do this, I still have a 2 that I'm trying to roll and a 5 that I'm trying to roll. But this time, since I have the word or, I'm not going to multiply my events. I'm going to add my events together. Okay, so if I roll a 2, I only have a chance of getting a 2 one time with a total of 6 sides. Okay, then for a 5, I only have a chance of rolling it one time with, again, a total of 6 sides. So if I add across the top, 1 plus 1 is 2. And then my denominators are the same, so they stay the same. And if I reduce this fraction, my probability is 1/3. Okay, go ahead and get started on today's homework.